COP1 is a coat protein which allows for vesicle formation and selective cargo packaging. COP1 primarily transports misfolded proteins retrograde from the Golgi to the endoplasmic reticulum and is also involved in inter-Golgi transport. Besides the coatomer, there are additional proteins critical for COP1 vesicle formation. This is a diagram of the lipid bilayer of the Golgi. The bilayer has a family of P24 proteins that are involved in cargo selection for transport. ARF1 is a small GTPase that regulates COP1 vesicle formation at the cis Golgi by recruiting coatomers onto the Golgi membrane. ARF1 is bound to GDP in the cytosol. A GEF catalyzes the exchange of GTP for GDP, activating ARF1. Coatomer, composed of 7 core subunits, becomes membrane-associated through interactions with the activated ARF1. ARF-GAP1 interacts with ARF1 and promotes hydrolysis of ARF1 so the coat can dissociate after fission. BARS is a protein critical in coatomer fission from the membrane. Phosphatidic acid, PA, is a cone-shaped lipid that aids BARS. PLD2 makes PA.
When GEF activates ARF1, ARF1 binds to the cytoplasmic tails of the P24 proteins. The activation of ARF1 recruits coatomers to the membrane. Not shown here, as ARF1 dissociates from the P24 proteins and dimerizes in the membrane, the coat begins to fold outward. The curvature of the membrane facilitates ARF-GAP1 binding as well. BARS, PLD2, PC, and PA are recruited to the neck of the vesicle to complete fission. Following fission, the increased membrane curvature stimulates ARF-GAP1, triggering GDP hydrolysis of most of the COP1 coat components from the vesicle. Leftover components of the COP1 coat may aid in the targeting and docking process on the target ER or Golgi cisternate membrane.